One more impulse example I wanted to show you is more of a graphical view of how to find the amount of impulse. And for this graph, I have a force versus time graph. So I have my force on my y-axis, my time on my x-axis. And so since we know that our impulse, our change in momentum, is equal to force times the change in time, I need to think, okay, on the graph, how am I going to get a force times the change in time? So if I wanted to multiply my y-axis times my x-axis, what is that? And the answer is area. So if you wanted to find the impulse of a force versus time graph, all you're basically going to do is find the area underneath the curve. And in this case, we have a triangle here. So if I wanted to find my change in momentum, or my impulse, I'm just going to find the area of my triangle, which is 1/2 times the base, so I have 2 seconds, times the height, which is going to be 100 newtons. So if I just wanted to find this, all I have to do is multiply it out. So 1/2 times 2 is 1 times 100. So it's just 100 Newton seconds. And Newton seconds is another way to actually show impulse. But we know from our standard unit of momentum, it's just 100 kilograms meters per second. And this is the answer. That's all you have to do if I give you a graphical point of view. But I wanted to show you this because it's important to understand that not every view that we have is going to be just a simple math problem. Sometimes you are going to have these graphical views and you're going to have to think about and figure out how to solve from the graph exactly what you're trying to find.